Hello everyone, this is a class on electric circuit, and in this class we will be discussing about the basic laws of network, that is Kirchhoff's current law and Kirchhoff's voltage law, that is KCL and KVL. First we will see Kirchhoff's current law. Kirchhoff's current law states that in a network, algebraic sum of current at a particular node is 0. That is, what is a node? Node is the interconnection of two or more branches. This is a node where there is two or more branches connect. So we can say that I'll mark some current I1, I2, I3 and I4 and also I5. Okay, here I have marked as I1 and I2 as incoming current, that is arrow is inward coming to the node, and I3, I4, I5 are the outgoing currents. Okay, and I have taken the sign convention that entering current is negative and leaving current is positive. So here the entering currents are I1 and I2. So entering current I have taken as negative, that is minus I1 minus I2, and the leaving currents are positive. I3, I4 and I5 are the leaving current, that is I3 plus I4 plus I5. And KCL states that the algebraic sum of the current at the node is equal to 0. So rearranging, we get I1 plus I2 is equal to I3 plus I4 plus I5. That is entering current. Sum of the entering current will be equal to sum of the leaving current. Sum of leaving current. This is another definition for KCL. So there are some features of KCL, that is, it is applicable only for a lumped network. Lumped network, what is a lumped network? See here in a circuit there are resistance, inductance, capacitance, etc. This is a lumped network. Then there is another type of network, that is distributed network. Example, transmission line. In a transmission line, there is no inductance or capacitance connected, but this transmission line shows the features or nature of inductance, capacitance and resistance. So this is a distributed network, and this KCL is only applicable for a lumped network. So, and it is independent of the nature of elements of the circuit, and it is applicable of this KCL is the application of law of conservation of charge. That is, we know that charge, that is we know that current is equal to dq by dt. Okay, so we have discussed that I1 plus I2 equal to I3 plus I4 plus I5. Thus we can write that dq1 by dt plus dq2 by dt is equal to dq3 by dt plus dq4 by dt plus dq5 by dt. That is, dq1 by dt is the current I1, this is current I2, similarly this is the current I3, I4 and I5. So from this equation we get that q1 plus q2 is equal to q3 plus q4 plus q5, that is the sum of the charges that is entering the node is equal to the sum of the charges that is leaving the node. This is the law of conservation of charge. Law of conservation of charge. So KCL is the application of law of conservation of charge. Next we will see Kirchhoff's voltage law or KVL. It states that in a lumped network, algebraic sum of the branch voltage around a loop is equal to 0. That is, this is a network where there is a resistance and another resistance. Okay, this voltage is V. Now we can see that this is an active source, so current will leave through the positive terminal. This is resistance R1, this is resistance R2, and here we can resistance as R1 and R2 are passive sources. In a passive source, current enters through positive terminal and leaves through negative terminal. So we can give here the positive sign and here the negative sign. Similarly, here also current enter the positive terminal and leave through the negative terminal. So this is how we put the sign. Now we'll this is a loop. Now we will write the voltage around this loop. So while writing the voltage, see the first while going through the loop, which sign comes first here? Minus V. So next here the voltage drop across resistance R1 is this current is I, then the voltage drop will be IR1 and the next sign will be the positive sign. Okay, next the voltage drop across resistance R2 is IR2 and the sign will be positive. While we have to see that while going through the loop, which sign is encountered first, put that sign. Okay, now this is V equal to IR1 plus IR2, or we can rewrite it as V is equal to V1 plus V2. This is Kirchhoff's voltage law, and it is also applicable for lump circuit, and it is independent of the nature of elements. Then it is the application of law of conservation of energy. We know that voltage is equal to rate of dE by dQ, that is energy per charge. So we can put here dE by dQ is equal to dE1 by dQ plus dE2 by dQ. Or from this we get that E is equal to E1 plus E2. Okay. So this is the law of conservation of energy. So this is about Kirchhoff's voltage law.